Okay, thanks so much for the introduction, and it's so great to be up here again. So I know right after my session there's going to be a little snack break. So to get everybody an appetite, I'm going to be talking about food. We're going to be talking about pizza. So the project that we did for Maestro Pizza, it was myself as well as Devin Cowling, and from Maestro Pizza side it was Basil Ayoub. And unfortunately they couldn't make it to this presentation, but I just wanted to highlight their names as being active participants in the project. So to start off, I'm going to talk a bit about the company and the background to the project, what was the type of questions that we wanted to answer. And in order to do that, you need to have a little bit of an understanding about the process flow, but it's actually something I think everybody is familiar with ordering fast food. And once we look at the intricacies of the process and why it's so complicated, you'll understand the need for simulation and why this is not a problem that you can answer with spreadsheets. And then we'll talk about why AnyLogic was our tool of choice when coming to simulation. After we've discussed that, I'll quickly do a demo about the single run functionality where you get to see the animation, drivers moving around, kitchen staff preparing the pizzas, and then we'll have a look at the sensitivity analysis functionality, which is the actual heart of doing analysis on most models. We'll look at some representative results. Some of the real results I can obviously not share, and then we'll have time for some questions and answers. So the company Maestro Pizza, it was launched in 2013, and it's now the most recognizable pizza brand in Saudi Arabia since 2019, and they form part of the bigger company called Daily Food. Now, back in 2022, Maestro Pizza wanted to optimize their fast food delivery service and improve the overall efficiency and productivity of making and delivering pizzas. So in the first phase of the project, they wanted us to help them determine the minimum number of delivery drivers to assign to each of their stores, to each of the shifts, to meet their targeted service delivery for orders being delivered to home locations. And additionally, they also wanted to test additional driver setup options. So for example, floating drivers, where drivers are not fixed to a specific branch, but they're able to service multiple branches. And then phase 2, which was done earlier this year, was about optimizing the staffing inside the stores to determine the optimal number of staff by the different types, so cashiers, drivers, kitchen staff, etc., by shift, again, to meet the target service levels of the preparation time, so the time to prepare a pizza inside the store. So just a bit of an overview of how the process works. So when you place an order for pizza, you first need to determine what's the type, right? So it's either an online order, which is done via a web interface or via the mobile application, or it's offline, so it's done in person at the store. And if it's done in person, somebody needs to take that order, right? You need to pay for that order. There's a certain time that's associated with that. And then all these orders would go into a check whether there's oven items or non-oven items. The oven items would go into a make queue, so the pizzas are sauced and cheesed and the toppings is added, and then they go into an oven queue and into the oven. Once out of the oven, they go into a cut queue. Once cut, it's joined with all the other non-oven items, and then you need to decide whether it's for delivery or not. If it was for delivery, it'll be dispatched immediately, so it goes into that queue where it's packaged, and all the items that was made as part of pizzas or the appetizers, desserts, etc., gets dispatched, goes into a delivery queue, and then gets delivered. If it is not for delivery, the question is whether or not the customer has arrived. So if the customer placed the order offline, it was in the store, the customer would obviously already be there, and if they placed it online for collection, they would not, so you would have to wait for that. So that's typically where somebody asks, order number 63, and you wait for that person, and if they're there, then you start dispatching it, and if it's not, you have to wait. And then the dispatch, and then whether they've paid. If it was online, you've got the option to say whether you're going to pay online or you want to pay in the store, and then they'll have to pay, and then they can collect it. So it's a pretty basic flow, right? It's not the most complicated model. But then we've got the 3 different type of resources that work in the system, and they are only allowed to do certain types of activities. So we've got our kitchen staff, they're allowed to do all activities. But when we look at the cashier and the delivery person, they can't do the cutting and the making. And to add an added complexity to the system, let's put in a part-time driver that can only do deliveries. So even though all of them can do a number of shared activities, the question is, how much do you need of each resource? and what's the priority in which they should do things, right? An obvious one is your kitchen staff can only do cutting and making, so ideally you would not want them to do the deliveries because they will be away from the branch for a long time. But at certain times of the day, you might have 3 kitchen staff and not enough orders to keep all of them busy, then you'd rather have them do the deliveries than assign another delivery driver. So this is really hard, and the question is, what is the right number? What is the priorities in which staff should be allowed to service the customers or do the preparation time, etc. So on that note, let's talk about the need for simulation. So we've got this requirement to measure the service levels of the customers with different system configurations, bigger ovens, less delivery drivers. And this is important because we want to improve the service levels and we want to meet our marketing commitments. If you we've got a 30-minute minimum preparation time or your next order free, you want to be sure that you can actually make that commitment. And thus you need to staff your branches optimally. Now, the benefit of simulation is that we can measure things that in reality you can't measure. Like you can measure every single thing that you simulate. In reality, you can't sit every day with a stopwatch and see exactly how the people are operating and what setup gives you the best performance. But in a simulation, you've got the ability to adequately analyze all the events. The second need is a cost-effective way to test changes in the system. And I think we've discussed this, and it comes up in a number of presentations, is that simulation is this fast way to test this. And in reality, if you were to make changes to your staffing schedule, it can result in a significant cost if you're assigning too much staff to a specific branch, or you can suffer a reputation loss, right? You've got too few staff, people are waiting, they're complaining, you have to give discounts, they will probably never come back, and you might even lose a customer forever. And simulation is this low-cost, almost risk-free environment where you can make these changes and you can get fast feedback without jeopardizing cash or, in this case, goodwill. So the need is to provide a range of likely outcomes for different demand patterns and staffing schedules. If you want to know how many part-time delivery drivers I should have on a Monday between 4 and 8 p.m., right, that number will not give you the same order service level rate every Monday, because every Monday is different. So you want to run a whole bunch of Mondays with a relative order pattern, maybe on historical orders, on future orders, and be able to see what the actual achievable target rate is for your service level. And this is needed because stores need to reliably meet the customer's demand now and in the future. And the idea is that in a simulation, you can easily and effectively vary these input parameters. What if our promotion will cause a 10% increase in the demand for this specific pizza on Mondays when we have our special during lunchtime? Okay, let's make that change. It's a simple input change in the model. You import it and you run it again. We also want to test the impact of changing the prioritization rules and the execution philosophy changes inside the model. So it's, for example, changing the priority of the staffing members who should do what at any given time. If you've got a cashier, they should probably do cashing first, and a delivery driver delivery, and the kitchen staff stick to kitchen making, right? So we are able to test this in the model easily by just changing some of the inputs. There's no logic changes required from my side as a modeler. Everything is changeable inside the input file that they import into AnyLogic. So we also want to incorporate various dynamic events and system interdependencies. The reason for that is they wanted to add the resource unavailability as well as resource task switching, which is again something that you can't capture inside Excel. So if a kitchen staff member who's busy making pizzas need to service the counter where they take the orders, it needs to remove the gloves, maybe wash their hands, then go and take the order, and when they come back as well. So we've added in task switching delays based on what activity the resource is moving from and what activity it's moving to. And so the benefit of a simulation is that it can consider all of these constraints, interdependencies, and the variability of events. So the benefits of using AnyLogic for this specific project, I think somebody else mentioned as well in the Amazon team about the use of GIS. So for the first phase of the project where we did the delivery of pizzas to customers, this was really great because you're allowed to do the routing on a real-life network. And we also included some historical traffic impact, so slowing down the specific driver speed at a specific time of day. And what was important for this project was the ability to download the maps and have them locally on your computer and not having to query the server for those routes and for map updates, etc. So we downloaded the entire applicable map from OpenStreetMaps, and it was distributed with the model to the client. The benefit that you would have seen from the process flow is that we could use the standard flowchart objects from the process modeling library inside AnyLogic to very easily represent the process flow as it is in real life and as it was provided inside PowerPoint. So this was great for verification and validation, and during some of the meetings we would actually look at the AnyLogic model and move a few blocks around and they go, oh, yes, that seems right. So it's a nice interactive tool to actually go through with the users if you are using the process modeling library blocks. The other big benefit is the seamless integration with libraries, any standard Java code. I know that's one of the big features in this project as well as previous projects. And I use this specifically when writing out the model output and the log files, which we'll discuss a bit more detail later. And then one of the biggest benefits for me always have been of AnyLogic is the ability to export the model and have that available to the client. And they can test it, they can analyze it, they can do future scenarios, right? The idea is never that you build a simulation model for just like a once-off run and only on your computer. It's great if you can share it with the client, and the model lives a lot longer than the actual project. Okay, so I'm going to do a quick demo of the single run functionality. So you'll see in the model is divided into 3 sections. The first one, the most important one, is the scenario loading. So as I mentioned, everything is data-driven. Everything is captured inside the scenario file that we've got here, and it imports into the model and then dynamically sets up everything. It contains everything that you need on a higher level in terms of model setup, the staffing schedule that you want to test, the task priorities, which I spoke about previously, where every resource gets allocated a priority for every task, some parameters around generating new staff unavailabilities, branch details, some general parameters. And then what was key for the second phase was this order generation logic, because you don't always have a massive set of historical orders, right? You want to model some future situation. So you can verify the parameters, what distribution of orders, etc. The last one here is the historical order input. So if you want to pull in 3 months worth of historical orders and say, how much better could we have done if we had more staff members? And you can compare it against reality. So if we go into the single run mode, so here we're going to be able to view the actual execution of the model. We've got this little table where we viewed all the branches, how many of the orders were within target. And this is, again, just some representative numbers that we're allowed to show inside the demo. If you click on any branch, we can see some very basic animation. We've got some charts there, and you can see in the staff availability for the different staff members, how they get utilized, and then there's a lot of idle time. We can view the charts at the bottom for the number of orders being waiting for cutting, delivery, etc. This was part of the first phase of the model where we simulated the actual delivery process. So you could view the statistics for the different branches. You can zoom into the location of a specific branch, click on any one of the drivers or the orders or even a branch and get some more information about what they're waiting for, what's the estimated time of drivers, etc. And we simulated all of the stores in one go so that you could get all the information about staffing, etc. on all branches, and you don't need to simulate a single branch at a time. Okay, and so this is all well and good when you want to view the model, where you want to test just some specific change and try and visually see what's the impact. But most of the time with any big model, as you would know, the idea is to run multiple parameter variations, test multiple things, do multiple replications at the same time. So with the same file that we've imported just set to one branch, we could set the number of days, which is essentially the replications, because each day is mutually exclusive from the previous one. In this demo, I put the part-time drivers to 0, so they're not going to be varied. We're putting the labor efficiency on 1, so we're not going to change that. And we're putting a minimum staffing mode, so it's going to tell you what's the minimum number of resources that you required. If we click on Run Experiments, you can see in the background it's created almost 1,300 different factorial combinations of the settings that we've got here. And after a few moments, it takes actually a couple of minutes to run, you'll be able to view the results, download all the details, as well as some summary results. And this is a text file, but you can just open it in Excel because it's tab delimited. And this is the real benefit of having all this data available to the client. And why you will see in this presentation, as well as some of the previous ones I did, that I never focus too much on putting charts and things inside the model, because you never know what is going to be analyzed. You don't know what's going to be changed in the future and what questions the client would have. Oh, I'm actually wanting to compare what if I change this priority versus the number of delivery drivers that get assigned. And now you need to go and build a chart for that just so that they can see that. It's more beneficial to make sure that all the possible outputs that the model generates is founded in the log files or in some summary statistics, so that it's always available. As you can see here, in less than a minute, I drew a chart comparing the number of delivery drivers versus the number of kitchen staff and the order preparation time. Right? And because all of the information is captured in the log files, the client can continue to do numerous analysis on its own without any of my attention. Okay. So a brief look at some of the representative results, and I can just show you. So we compared, for example, the minimum number of drivers by branch and by type for each of the shift, days of the week, etc. So in this example, you can see that on Sundays for that shift, we needed 5 fixed drivers on average and 1 floating driver. And these charts were then drawn up from the log files for each one of the stores. And we also looked at the service level distribution by store, by day of week. It's like, how close are you to what you promised the customers by day of week and by each one of the stores. We also did a correlation, as I showed in that other example, about kitchen staff versus the cashiers versus your drivers. And as you'll see there on the first chart on the right-hand side, having more cashiers didn't make any impact on your order time. It stayed flat, regardless of the number of kitchen staff that you got. Which kind of makes sense. If a kitchen staff member needs to take the order, it's not really wasting any of that order time because the order needs to be taken first, and it's actually a very short duration of activity. Where if you look at the bottom one, if you add delivery drivers, it actually decreases the time to prepare the orders, because if a kitchen staff member needs to go and deliver an order, it's actually gone for a lot longer. And there might be other orders coming in during that time. So it is better to have an additional driver than additional cashier if you want to minimize your kitchen staff. And there's obviously a cost implication for the different types of resources that you've got. And so the majority of all the results that you see here is only gotten from the sensitivity analysis, because else you're just looking at one replication in your model, and you don't know whether that is on the far end of the spectrum of possible results, and so it's possibly not the average. Okay. So that's it from my side. If there's any questions, you guys are welcome to ask now or contact us via LinkedIn, or I would probably be posting about this on the blog after the conference as well. Thank you so much.
I'm over here. I really liked what you said about not bothering to spend too much time making visualizations in the output area, because the client is just going to probably download to Excel and do their own analysis anyway. Did you, so you did leave it behind with them, and do you know anything about what they have tended to use it for, or what they've done with the outputs, and if they've used it to change anything about their operations?
Yes, so definitely on the first part about the delivery drivers, they really tested this floating drivers, and not just whether you should do floating drivers, but what branches should you club together to allow a floating driver to service those. And on the kitchen time as well, kitchen model as well, it's all about what the staffing was. That was by far the biggest requirement from this, and they are actually currently using it as well.
Did you consider using like third-party delivery drivers at all? Was that something that they put into the model?
No, I don't think that's something that. When you talk about third-party, is it like Uber
like
Eats?
Uber Eats or
no, I think that's separate. That would be counted as an in-store customer making an offline order. So that's not part of what they are responsible for, but it would probably be captured inside the demand as well.
Hello, over here. Curious to know how the order schedule was generated. So I did see that you drag and drop some kind of file, and boom, you have your like order schedule for all the sites. But did your customer provide like, around this time for this region, the sites are about to get 10 pizza orders. Next hour it'll increase to 20. So were there this discussion about like, hey, this is how we should create the order based on the input? Just want to know the process of it.
Yeah. So there's two ways of running the model. The one is with an historical input. So that's really the orders. At what time did you receive an order for these items, like 3 large pizzas, 1 half and half, 3 cool drinks, appetizers, dessert, right? So we're resimulating history as is. But the problem comes in when that is your only input into the model, and people say, look, we're going to run this promotion on Wednesdays. We think demand's going to increase by 10%. You can't just take this file and increase it by 10% because it won't change any of the numbers, right? 10 of 3 items is not going to make it 4. So that's where we've got this alternative way of running the model. So it's a checkbox in the model setup to say, either historical orders or order generation. And then in the order generation, you've got this distributions and inter-arrival time between orders, which they can specify by hour. And so that's more like experimental results. So there you have to input some smarts and saying, I think during lunchtime, the Poisson distribution for the inter-arrival rate is going to be 100 seconds between orders, when normally it's about 200. So it's a different way of running the model if you're running this possible futures.
Hello. Thank you so much for your presentation. I was wondering in your model if each branch is the same in terms of layouts or the expertise of the employees, and then as far as the output, if each one of them will have the same staffing level, or the model will determine what's the optimal number for each type of work and for each branch differently.
So in the input files, everything is specified by branch. How many ovens does it have? What's the number of pizzas per oven? Because there's different types, and the schedules, and most of the things is specified on a branch level, except like item preparation time, that's standard, and then like the schedules, etc. And in the output as well, it's done by branch, where you can see the different results. But in terms from a modeling perspective, the branch is just an object which is completely parameterized from the input of the Excel file.
Okay, so there's no layout where people are working or moving around?
No, it's not a network model where we physically want AnyLogic to calculate if you travel at this speed and you need to move in this from this to that location. But what we do have in there is, like I mentioned, the task switching times, and there's delay times, and that's also specified by branch. So if a pizza needs to move from the oven to the cut table, there's a 5-second delay, right? And for another branch, you might input it as a 7-second delay. Or task switching at this branch is slightly longer than at the other branch. So essentially, it's just adding an additional column in all the input files and specifying it by branch. But so those things were specified, and it was not done to the level of a layout.
Okay. Thank you.
Thank you for your presentation. Can you elaborate a little bit about the prioritization rules that you used? And did you test different prioritization system? For example, are we trying to minimize the average order time or the maximum order time for the entire orders? Just curious about how you thought about this. Thank you.
Yeah, so the prioritization is thus just done on the seize block, when you have to seize your resources. The resource set that we provide to that block is a function that says, okay, the prioritization rule currently that we're testing is for caching. It must be cashiers first, then delivery drivers, then kitchen staff. So it provides that 3 sets, because it is a dynamic input inside AnyLogic. And so there's no, when you mentioned what was like the objective function, that's not something that's considered. It's just saying, if I run with this rule set, what will my service delivery be? What is that distribution? What's the average? What's the number of orders completed within target? So the priorities is just done on that specific moment in time, who's available to take the customer order. And one of the potential increases would be to put some smarts into that, where you say, well, I'm not going to seize the kitchen staff now because there's new orders coming in, or there's a delivery about to be made, or a delivery driver is about to come back. And the reason for that is that in reality, there wouldn't be that. Right? It would be a case of, okay, guys, here's an order. There's a delivery driver sitting there, and the kitchen staff is idle. who should go and cache it. So it's something really practical that you can implement in reality as well. So it was just a flat, these are the priorities for every activity, just a sequence of different resource types. But a good question, thank you.
Hi, Jacobin. Quick question. So the way I saw it, you first defined the process flow, then built a model, and then made some recommendations after running the simulation. My question is, how was the model validated for this particular one, which kind of helped you earn trust of your customer to implement the recommendations that you would be giving? And in general, what's the procedure that's used to get a model that you're simulating to be validated? What are the general guidelines on it? Thanks.
Yeah. So if we can just summarize, your question is about how was it verified and validated?
How was the model verified and validated?
Yeah. So in this one, and that's probably why there's not this fancy animation and 3D and so on, because it wouldn't add that much value. But what happens with those log files, it is by item, by order level, who worked on it, who did what on it, like who took the order, and then so many seconds later it would start making, then it was cutting, etc. And Basil actually did a very good job of literally going through all those things and make sure that it makes sense in terms of timing and sequence and who worked on it, at what time, etc. So in the log files, it was essentially putting a filter on it, following the process flow of a specific order and making sure that it made sense. And you can also filter out all the ones where you had very long completion times and try and figure out, okay, what went wrong? Why was there no resource at this time to do this? Why did it spend so much time in the queue? So it was really low-level validation that we're using the log files. Okay, thank you so much for all the questions. I can't see anyone else. Thank you.